Alright, so let's talk a little bit about mean standard deviation, probability. Hoping by now that you have watched the videos that was posted on Angel. I post a lot of Mr. Khan's videos. He's got quite a few on many different math and science subjects. I encourage you at any time in any classes to go there and take a look. KhanAcademy.org. So where do we come up with this P? Where do we come up with precipitation? It's basically accumulation of many. We use statistical methods, so to speak, to determine, what is our 2-year event, 5-year event, 10-year event, 25, 50, and 100 based on historical data. Really, that's the best we can go off of. So we go off a statistical measured value from historical data. If you are reminded from the videos or even from your own background, we've got a normal distribution curve, and I apologize, I'm still getting the hang of this tablet. And right here you're going to have the mean, the most probable value. Right now we're talking about this in surveying, as it deals with survey errors. There's the reason we call it the most probable value is you have a 50% chance of this occurring, and you have a 50% chance of that side occurring. So you have just as much of one occurring as you do the other. Let me erase this. There we go. And redraw my curve here. So now we've got the mean right here in the middle, the most probable value. And again, I apologize for not drawing a straight line. When you take a group of data, all of your data will fit within 3 standard deviations of the mean. So 3, we'll put our 2 here, we'll put our first there. So -1 standard deviation, -2 standard deviations, -3. So in surveying, we often say that we want to find the 95% error. What that means is we measure a line, a couple of foresight, backsight. We determine that the average is 100 feet, and the error is plus. Wow, look at there. There we go. Plus or minus 0.005 feet. All right. So what that means is, and what you'll find, what you should remember, at least from Mr. Khan's video, is that 67% of all your data should fall within 1 standard deviation of the mean. So I believe it's about 67%. And then a little over 95% should fall within 2 standard deviations of the mean. I believe we actually take the standard deviation and multiply it by 1.67, if I'm not mistaken, to get the 95% error. So it's a little bit less than 2. We'll just call it 2 for our purposes. So 95% of your data will fall between -2 standard deviations and positive standard 2 deviations. So what we're saying here is we're saying plus or minus 0.005. So we're basically guaranteeing with a 95% certainty that our greatest value will be 100.005 feet, and our smallest value will be 99.995 feet. So that's pretty good. So we're off by, what is that, 5 thousandth of a foot. Tens, hundreds, thousands. Yeah. So so that's, you know, a very, very small, smaller than an inch. Inch will be 0.08. So very small error there. But basically, that's what your error is. That's what we talk about when we talk about our error. We're going to do the same, somewhat of the same thing as it relates to precipitation. And we'll talk a little bit about that in the next video.